So the idea behind accumulation, this will be your homework. Make sure you cross this out. This is supposed to be AP calculus. So this is homework. Approximating area under the curve. So this is pretty easy. If you had to find the area under the curve, let me highlight what area I'm talking about. Bless you. Oh, that was juicy. You heard it. I got it on YouTube. Okay.
That's not precise. I get information.
I've been hanging out with you guys too long. Okay. So here, if you had to find the area of this, it would be easy because it's a common figure. We know how to find the area of a circle, so that means we know how to find the area of half a circle. So let's find the answer to this area under the curve for this curve using the geometry that we already know. So the area of a circle is pi r squared, so that means the area of this circle would be pi, radius is 8 squared, so answer would be 64 pi, which is, that's the exact answer. To find an approximate for that, 64, whoops, 64 pi. Area would be about 201,062 units squared.
What did you have to have?
What did what?
Did you have to have half of it? Have a 200.
Oh yeah, correct. So this would be divided by 2. So that would be 32 pi, which is, divide this by 2 would be 1 100 point. This is a little tricky, 0.531.
Oh yeah, that's true too. Not the best one.
I just divided by 2. It was a little tricky. What, in my head? Well, I mean,
He majored in
I've been doing this a while.
Calculator right there.
Right. So anyways, that's the area. We can do this for curves that are not nice. So this is a nice semicircle, so we can use geometry, but we're going to use calculus to find it. Starting today, we are actually going to look at approximating the area. So we're not going to find the exact area today, it's just approximating. So let's look at this. There's a method called the left endpoint method. And here it says using 4 rectangles of equal width, use the left endpoint method to approximate the area under the curve between x equals 0 and x equals 4. Okay, so I'm going to zoom out a little bit. Well, now I'm going to zoom in. Okay, so here's what this looks like. From here, oh wait, what is it? From 0, between x equals 0, x equals 4. Alright, so I don't care about this right now. I'm just going from 0 to 4. Okay, this area, so I also don't care about this. I only care about 0 to 4. So if I had to break this up into 4 rectangles, 4 equal widths, I'm going to have something from 0 to 1, 1 to 2, 2 to 3, 3 to 4. You see how there would be 4 rectangles here. The heights of the rectangle are going to be decided by looking at the left endpoint of each triangle. This is where I wanted to zoom in even further. Okay, so zooming in, I'm going to change the color so I can focus on just one thing. Let's look at blue. Okay, so for this interval right here to here, 0 to 1, this is my first interval. Which is the left endpoint?
0.
0 is the left endpoint. So I'm going to use this to find the height. So I use 0, and I go to the height of the function, which is here. And then I create a rectangle, which is easy to calculate because I know that the height is exactly 8. So this is going to be the easiest rectangle to find on this. Any questions so far? That shouldn't be too hard. It is going to get harder on this problem. Let's do orange. No, let's do this. Okay. Did I do the same color? Okay. So now from 1, that is the same color. It's still not doing.
It's probably a different kind of pen.
You're a different kind of pen. Alright. Fantastic. Oh, it changed. Okay, so from 1 to 2, which is the left endpoint? 1 is now the left endpoint. But I can't go all the way up to 8. I'm only going to 7 point something. And then I go across and make it an exact rectangle. So the height of this is going to be kind of weird. How do I find the height? How do I find the y value here? The height of this rectangle based on the equation? Yes?
Slope of the tangent of the derivative at that point?
No. So I'm just trying to find the height, which happens to be the y value.
Approximating. Proportion.
Since I have
Sine of 1.
Since I have the equation, I can find this y value by plugging in 1. F of 1 equals 64 minus 1 squared, and then square root that. So that would be the square root of 63, which is what? .937. Okay, so do you see the geometry behind this? The height of the rectangle is decided by this equation, because f is just this is basically your y value, or the height of any of these rectangles. So how would I find, what would I do on this next one? So same, rectangles up to here, cuts across. I don't care about this side until the next rectangle. But what's the height going to be here? Plug in the left endpoint, which is 2, so find f of 2. would be square root of 64 minus 2 squared, square root of 60. $7.746. And then what would the last one be?
93.
So left hand side goes up, stops at the function, goes across and down. So here I would need to find f of 3.
Square root of 55.
64 minus 3 squared. What did I just do there? The window moved. I got confused. I don't have an apple.
Control C.
Control C. It's Control C.
Okay, so I messed up the, here's my rectangle again. So here I need to find f of 3, 64 minus 3 squared, which is 55. 7.416. Okay, so how would I find, let me zoom out.
Okay,
So how would I find,
add them all.
I would have to add up the areas. What is the base or the length or whatever you want to call it of each of the rectangles?
1.
They're all base 1. So the areas are just going to be, add them all up. It's just going to be 8. 8 times 1 plus, what was the green?
7.937 times 1 plus 7.746 times 1.
This is a 7.
Yes, sir. Plus 7.416 times 1.
So that's what the area would equal. It'd be 4 different rectangles. Here's one rectangle, 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 rectangle. So what do you think, and what does that equal? It's not huge. 8 plus 7, 937.
Plus 7.74.
That's around 28 or 29. Little squiggly lines.